My name is DesMarais. Today we're going to talk about unlocking the software-defined vehicle for defense innovation. We'll talk about what software-defined commercial vehicles are doing. So talk about the basis for it. Software-defined vehicles in defense. What's different? That's what we'll talk about. What's needed? What do we need? And then what's the concentration on the problem? Okay, so we'll talk about all these areas. So the future of automotive is software-led. This is absolutely we're engaged with a lot of different automotive companies. It might be on one of the slides. It probably is. We're in 235 million cars today. Stephen and I do not work in the automotive group. Stephen and I, as you pointed out, we work with the medical, industrial, space, aerospace, more broadly, defense, rail. When we said transportation, we were talking about rail. And BlackBerry does safety for all those areas, for industrial, for medical IEC 62304. We do 26262, which is safety for automotive. And then rail is it's EN 50128, and then there's a rolling stock. Rolling stock is not the engine, but basically the cars and the yard. That's what's referred to as rolling stock. But software is central today in shaping vehicles and what vehicles are doing. The software defense, they're opening new doors. I never really noticed that. That's not literally. Well, it's kind of literally. They probably are opening doors toward that. But mostly digital cockpits. We're in the instrument panel. We're either hosting or in the infotainment. And a lot of times what you find in engineering problems is you want to combine them to reduce the amount of electronics. We'll talk a little bit about that. But so you want to mix safety and non-safety functions. The last thing you want to do is to change the radio station in your car and your car stops working. That would be listed as a bad thing. You want to make sure that your car continues to drive no matter what's happening and everything else. It drives me nuts when I'm on a Microsoft Windows or something, and the mouse stops. It just, I don't keep a gun in my office because I would probably shoot the computer because it just drives me nuts. I'm kidding, by the way. So I do keep a gun. All a joke. ADAS. There's four pillars of automotive innovation, vehicle innovation: connectivity, autonomous, shared services, and electrification. Anybody hearing any of these in the news? Probably at least. The connectivity, not so much, other than that everything's going to be connected to the cloud, which is part of the shared services. So in a way, those two are connected. Autonomy, everybody wants autonomy everything. Okay, you get in the car, I rented it's a Hyundai or something like that. You turn on the right blinker, the little camera comes up on the right side of the vehicle to show you where the curb is. This wasn't around 10 years ago. It wasn't around 5 years ago, that much. The innovations are getting there. We'll talk a little bit about those. Shared services and electrification. Our president really wants to see more electrification as well. What are the challenges? Reducing complexity and cost is a huge challenge in automobiles. How do you reduce complexity and cost, especially as you go to software? Is software more or less complex than a bolt? It's a little bit more complex. So you're driving a little more complexity. You want enhanced user experiences. What does that mean? You're going to enhance the user experience, and you're also going to gather information that's going to enhance the vendor information as well. When you pull into a station, you're going to be able to pull up in your electric vehicle and get a refill, and you don't even have to get out of the car in most cases. Well, you probably have to get out of the car to plug it in, but you know what I mean is that you barely have to get out of the car to do these things. The new revenue models I was talking about, vendors. Harness the power of the cloud. What can I get to the driver while I'm driving? What can I get to the insurance company? What can I get to the rental car company? as you're driving. These things are kind of scary to me because I'm kind of one of those privacy guys. But these are things that are coming in your car. Your car is going to have a lot more connectivity. And when with that connectivity, are both positive and negative. Implement with velocity. You want to be able to turn everything around. One of the main reasons for software-defined vehicles is being able to react and update. Right? You can't update your car today. They have a recall. What do they got to do? They got to bring your car in. What are they going to be able to do? What a lot of vehicle vendors are starting to do now, where they're going to update in the field. Hopefully not while you're driving, depending upon what it is, but they could update the radio while you're driving. There's no problem with that. But they don't necessarily want to update the steering system while you're driving. But that's the idea, is being able to update and modify and offer new services. There are things that weren't available at rollout of a vehicle that are available now, so you can do things. An increased emphasis on safety and security. Sure.
From the connectivity side, so the big drive like 5 years ago for we've seen that growing 5 years bigger. Do you have something like that?
I think the proliferation just hasn't been there because it's a lot of infrastructure. What I do think you have is a lot of the vehicle to vehicle is probably there, but not as much the vehicle to infrastructure. It is what I see now.
Yeah, a lot of times it's 5 years out. So even if you were seeing it 3 years ago, people were developing it. You got to coalesce around some standards, and then if that's deployed nationwide, then you're going to be that. It's testing.
I mean, we were 10 years ago probably, and BlackBerry's a Canadian company, Ottawa. They were doing an autonomous vehicle around Ottawa 10 years ago. 8 years ago.
The one that the big splash was 6 years ago.
6 years.
Where we drove the mayor of Ottawa around the city.
So, I mean, a lot of these technologies are around. And if you ask me, so actually, Stephen and I both spent some time in the space arena. I did space shuttle and I did satellites and inertial navigation systems. When somebody says something about autonomy, I'm like, we're doing autonomy 30 years ago. You think that there's somebody in that Voyager rocket that we sent up there? No. It's receiving commands from the ground, but it still has to do a lot on its own. Because you're talking about minutes. Does anybody have a control system where a minute is a good time to control the direction? Unless it's a satellite, no. And even some satellites, you want to point them a lot quicker than that. So we were doing that a long time ago. What also bothers me is when we call everything cloud now that I'm on my platform. Because it used to just be a mainframe. It's like, I'm from a time where you couldn't have a computer powerful enough to be able to do what you needed to do at your desk. And then the PC came, and everything was wonderful, and everybody had a PC on their desk that was more powerful than the mainframe from 10 years ago. And now, well, you know, we want to centralize some of this information. It's just going back to some old technologies with new words. So I appreciate it. And then just increase functional safety. ISO 26262 was the automotive functional safety. We also work with medical customers to do robotic surgery, eye surgery. That's IEC 62304 is the controls for that. Software has its own safety functions. And then I think this is kind of true of a lot of areas. You're going to see more modularity, more nodal, more dividing up of the car. As you're doing more and more in software, you can coordinate with message passing and have zones of the car so that you're doing that. Now, BlackBerry is very involved in a lot of these because, well, we have the RTOS, real-time operating system that's used for the automotive safety, but we also have an operating system that's it's microkernel, so it has a lot of flexibility between areas. But the software-defined vehicle is going to be kind of a modular approach to a lot of. I think that's important to the overall. This is where I think that the technologies are today. And then what else? We were talking about data collection and bringing it forward. BlackBerry has products that we're introducing now that we probably about a year ago started doing it to the automotive sector. And we've had some announcements around this where we're changing the way you measure your battery. Okay, and what are you doing with that data, and how is it being, the battery, what goes into the health of a battery, the temperature, the current draw, the voltage, all these things. What you really want is to know the health of the battery. So you have a synthetic sensor, and you do that with some of these technologies. What can you do with raw vehicle data? Well, you can upload it all, or you can upload conclusions from it, which is a little more where we've gone, is looking at the conclusions as opposed to the raw data. Yes. Yep.
It seems like difference from what you said. I'm asking this. The car that I don't know how many.
It's a few hundred. Probably a couple hundred. It's over 100.
And are you saying now we've got something that's going to put all these together today?
I think
that it's over and you can take something other thing.
No, I work virtually with the automotive vendors, but what I'm hearing is that there's going to be a little bit more there. Reduce the wiring systems. It's one of the motivations. Yes. We are an operating system for vehicles. I'm trying to talk more about technologies but we make an operating system for vehicles. Yeah. We are in 26 out of the 27 electric vehicles. Am I promoting that? I'm trying to sell it from a company standpoint. Am I promoting it? Yes, but we're in like 26 out of 27 electric vehicle manufacturers. We're in all of the Big 10 automotive primes. We're in a lot of the secondary markets, but there are cottage industries that are smaller that tend to pop up and then they come into the fold later.
When you say you're in, who are your competitors that are also, and are they in those cars also?
We do have competitors. In some cases, we coexist with some of our competitors. I would consider in some instances Android a competitor, in other instances a partner. They want to control and do a lot with the data. We want to control and do some with the data. I would consider Linux both a competitor and a cooperative type of thing. We try to stay within our lane, so to speak, but well, they don't do safety. They like to think they do, but they don't really do the safety of the level that you need to do a fun thing. And it's pretty tricky. It's a little bit more than just that. So we coexist. We work quite heavily with Android. I'll talk a little bit about some of the virtualization. But this industry is a small industry. A lot of us know each other here, there, everywhere. We coexist, we compete, we do everything. And there are direct competitors to us. Especially if I'm going to talk about defense vehicles, there's a direct competitor that's larger than us in that vehicle space, whereas we're larger than them in the automotive space. It's a contested market, yes.
My understanding was that most, if not all, of the data collection required often from the user on the side. That's not the case anymore. Is data being collected without their knowledge and consent?
So first of all, there's US versus Europe. I'll start with that. Okay. Europe, you have to opt in. In the US, you should opt in, but I think it depends on the data. It depends on whether the data is personalized or not. I can't think of the other word, so I'm going to say personalized. So I think there's a little bit of different law system in the U.S. than there is in Europe. Europe has much more. Remember what's the specification that they have? Yeah, there's a
under GDPR.
GDPR, right? Global data privacy something.
So what you're
Probably
saying
in
here
French.
is, what you're saying is in the US you can get away
No,
with
I think
things-
you still get a lot more positive, but I think what you're seeing, like when you go pick up your rental car, I bet you that if you looked at that agreement, it's telling you that you're giving up data. I don't think there's any doubt in my mind that they're just telling you that they're going to take your data and they're going to monitor your driving. And eventually they'll start doing that into a little bit higher level. They're loaning you a $30,000, $80,000 car. They're going to tell you have to do that. But when you do that, you don't want to necessarily, you collect a lot of raw data. You don't want to necessarily put it all into AWS, which is one of the, we can go to AWS, we can go to Microsoft Azure. So we have different solutions. Because of the operating system effect, we try to kind of be the foundation, not every solution. So that's why we end up cooperating and competing more. So they want to be the operating system, but they're just still some. I think there's a gap there. But they would argue. So I'm not here to argue it. I'm just here to say where I think things are. And then you want to do some vehicle data processing. You don't want to upload the battery temperature. You want to upload the battery health. You want to upload this because of bandwidth requirements and data requirements in the cloud. That's what this solution covers. And then it also is working towards providing methods of payment based on that. You could upgrade your car, have a different functionality. In this car out here, the Hyundai I was talking about, there's a dial where I can change it from regular driving to sport driving. And the suspension and the feel changed when I did that. I probably shouldn't have done it while I was driving. Yeah, it wouldn't let me navigate while I was driving. Even if I was stopped at a light. Anyway, so that's kind of what this is, but it's just another area. I'm not going to tell you that we solved all these problems in the last 3 years. Whoops. I'm just saying that these are state of the art. These are where things are in automotive. So how does that relate to defense vehicles? What's different about a defense vehicle? What's the same about a defense vehicle? What do you need them for? Surveillance and reconnaissance is one of the big things. What's one of the biggest drawbacks to having an airplane in the air that's with people? They have to come down a lot sooner than a drone does. That's just doing that. You're solving problems like that. Okay, going surveillance, reconnaissance, explosive ordnance, and bomb mine clearance. Is there a good reason to automate that? Anybody see Hurt Lock? Probably a good idea not to have humans in that region. Solution: urban warfare, logistics, supply, troop following. If you have a little vehicle following a troop or people running alongside of it, it's a little better than having them carry. I don't know, how much was a man pack in World War II? 45 pounds? Anybody know? I mean, nobody was there, but I'm just saying that it wasn't a light thing. You had a limited amount of range. Well, I mean, if your follower would do that, convoy protection. I have people in these, I want to protect them with others. So there's functions that you're trying to solve with this. What are the key technology drivers? We were talking about some of those: electrification, autonomy, flexibility, and scalability. One of the big things about vehicles in that space, when you have a vehicle in your car, you're not necessarily changing out the tires or the cockpit for every time you go somewhere. And in airplanes, you are. You're changing the entire makeup of an airplane when you're going on one mission over another. Flexibility and scalability. Predictive maintenance is going to be big in the cars, but it's also big and it's probably bigger in the There's many countries engaged. These are some of the common tactical trucks, Janko Light Tactical. These are European. JLTV, Joint Light Tactical Vehicle, is the replacement for the Humvee. Light utility vehicles, logistics vehicle modernization, Canada. So there's a lot of countries involved in trying to change the technologies that are in their defense vehicles today. So what's needed? Levels of autonomy. Okay. Level 1, driver assist. The lane modification drives me nuts because apparently I never put my blinker on when I change. Okay. And you start to go over it, it's fighting you. Can you imagine being in a 737 MAX and the thing is trying to nose you down because it thinks you're, or nose off, I forget which way it was going, because it thinks you're in a dive because the pitot tube is blocked. That's the kind of feeling I get when I try to change lanes, and it just assists me back in. Maybe I'm going into some construction and that's what the lane's doing and it's following the wrong line. It's not one I personally like, but the automatic braking has probably helped me because you're looking off on the side of the road, you're doing this, you're doing that, and it tells you, oh, wait a minute, we're going to slow you down. I like the adaptive cruise control, kind of cool. It used to be you'd set it and then you'd click it down a couple of times to go 2 miles an hour slower or 4, and some are 1 mile per hour each, some are 2. You'd have to just actually do that. You'd have to be paying more attention. I come from Phoenix area, Scottsdale area, where in Tempe was where I think it was the first traffic fatality of a pedestrian. I think that there was another crash of a Tesla before that, but this was the first one with a pedestrian, and they just ran into her. And if you look at the person who was driving that, it's not their fault. You cannot actually pay attention at a certain level of autonomy to watch a computer do its work. You cannot psychologically engage within it that long. There was a problem in the thing, like the automatic braking systems, and then the full autonomy. The thing that's wrong in this full autonomy picture is there's a steering wheel. Okay, there's no steering wheel in a full autonomous vehicle. I don't know that you're going to see that for a while. I predicted for some time that I think that the air taxis are probably going to make it first, and one of the reasons is liability. Because the liability, Ford, sold you a car that's autonomous, it gets into an accident. Whose mistake, whose fault is it? I think that's really the drawback of that is partially a legal drawback.
Of course, we say being there technically, but not about the security. Now, that security, somebody's trying to tap in and get stuff, or what?
It makes security more important when the vehicle is driving itself, because you can take over the vehicle, you can take it over completely. And now the occupants. Oh, it could be a bad guy. It could be mostly bad guys. I mean, I started to say it could be just somebody playing a joke, but no, it's mostly people that mean harm. There are people who are trying to hack into our medical systems now. Why would you ever want to hack into a medical system? Gain information or hurt people. I mean, it's the reality. Security. What's that? Ransomware is another one. It's actually a huge one, which is part of the problem with the $1.3 billion or $1 trillion per year, whatever. There's some large amount of money. I think it's trillion, but a large amount of money that's involved. So there's basically levels of autonomy. 0 is no autonomy. 1 is, features, automatic braking, partial automation, letting the car park itself, backing in. My kids, I don't think they really, well, I made them do it, but they had a hard time doing parallel parking, and now the car can parallel park itself. When I'm in this car out here, there's so many cameras and things showing me the curbs and everything, and I still hit the curb.
I didn't know.
Because I was looking at the machine. It's like, instead of, I'm like looking at it, and it's kind of weird. And then there's conditional automation and high automation, and then there's full autonomy. There's problems with any of this, but when the vehicle can drive up by itself, you see that a lot in drones, but you don't see it so much in the cars for the reasons I was talking about. I think of some of them. So Stephen's more aware of this, but the DARPA Defense Advanced Research Projects Agency had some challenges for years and years. 2004 was, I think, the start. I think even 1990.
2004 was the first year of competition.
Right. I think in 98 was, I think, the first one. We have a different slide that has a little bit more detail on it, but there was no vehicles that finished in 2004, but by 2005, 5 competitors finished. Autonomy is not new. Getting it out into the public is, but the autonomy, and I said about the space vehicles. And then they've been increasing technology funding for this
Yeah, the next slide shows.
in different ways. Yeah.
So what basically
I will talk more generally than that, just for reasons of I'm on tape, first of all. There are Air Force facilities and there are Army facilities that are involved in autonomy, and they're spread throughout. I'd be happy to talk to you offline, but I'm not going to talk about it. There's several. I mean, I know there's several. So Fort Belvoir is probably one of several. There's already autonomy in drones. There's already autonomy in others. I don't want to do it on tape. And then Army is you found this article is Army's testing their first autonomous vehicle for them. They're in the news. It'll tell you in the news, but I just prefer not to because I visited some of the sites, or some of the people that work with those people. But we were in a lot of the DARPA Grand Challengers, and 2004 zero finished in 2005, but now we're seeing it go to more autonomy. Any comments, Stephen?
No, I think the other point is you look at the funding, there's a lot of funding going into research area. So you're going to see a lot more vehicles come out, a lot more features come out because of this research.
So there's nominal inflation adjusted. I guess we did it backwards instead of forwards from the matching. And then there are moves afoot from Air Force, one of the biggest ones into the future airborne capability environment. But a lot of the automotive market has, not automotive, but the defense vehicle market, defense anything. It was legislated last year that the modular open systems approach was to be standardized across U.S. government programs above a certain amount. Face future airborne capability environment. I know it says airborne in it, but it's adopted by a lot more than that. We're in the operating system segment. What it does, it brings a conformant base of commands so that when somebody's integrating with someone's software from Rockwell Collins or from us or from BlackBerry, I'll say us, I should have said BlackBerry, or from one of our competitors or whatever, then you want to have the same look and feel. It used to have LD and LS, list directory and list something. I don't remember what the S stood for. But you had different commands when you were on Unix. I'm old enough to remember Unix versus Sun OS versus something else. They're different commands. And that's not good when you're trying to integrate from multiple vendors. Yes.
AI parts of all things are just sort of pushed aside because some of the special, things on restrictions.
It's a part of the overall solution. Everybody uses AI as the word. More often they use machine learning, actual reality, which is kind of a little bit of a younger sister of it. When you're trying to identify something, one of the problems I think when the vehicle in Tempe its identification of that was that a person, but she had a bicycle. Now it depends on your training data on what you're doing. There are ethical considerations of all of these things that oh, okay, maybe that person's abnormally short. When I think one of the first ones from one of the big vendors in California did their electric vehicle. I think one of the problems with that one was they hadn't turned on all the different things. You can paint a picture of a little girl in the road, and an autonomous vehicle that's just using video will stop at the little girl. Whereas if you have infrared, where you can see that there's nobody really there, so you're using multiple technologies when you're doing autonomy and when you're doing some of the machine learning. Yes.
So, we talked about
Yeah, and when I said that, I haven't gotten there yet,
yeah,
frankly. Yeah, well, I'll talk a little bit about it because there's some actually very cool things that we're doing. When I said that we were cooperaticians with Linux and Android, one of the big things we do is we host Android on a lot of vehicles.
and my question is, we're using that type of leverage some of the API integration.
Yes.
Although face, when you're calling out the face, it doesn't require a hypervisor. We have a hypervisor.
But you have a standalone as well.
Right, so face itself, the operating system thing does not call out hypervisor.
But having to put everything on a hypervisor, add the layer.
Yeah, we'll get to a slide
So-
that'll show you what that.
The answer is you don't want to put everything on the hypervisor. You want to put the things that aren't crucial, things that make sense. That's a good way of putting it. So, but this is just a specification. Mostly what the government's trying to do is to use specification to do that. The way that we use our operating system, this is kind of the microkernel view. Probably one of the few slides that's just basically about our operating system opposed to our competitors. Like Linux is a monolithic kernel, we're a microkernel. We keep everything out in user space because we want to keep it focused on the most important things. And it's the way to control it so that when your networking driver goes down, it doesn't bring your system down. It's important in space as well. When you get a single event offset, you want to reduce your exposure. When you have security, you want to reduce your exposure. You want to reduce how much someone get in and elevated privileges is essentially the corollary to this. Yes.
So, if I was one, so it's gonna have to be different to your flavor of electronics, besides with context. What's the big differentiator between your?
FreeRTOS runs in microcontroller.
Yeah.
We run in microprocessors. Okay. We want the full virtualization. Stephen said that a lot of the face spec that we were just talking about doesn't really say you have to have a hypervisor, but it does introduce some concepts of separation of functions where you kind of need to do it with a hypervisor.
But it's all of that. You have a different hardware, SOC requirement.
The particular thing that's different is we have to have, I just got the memory plan,
The full MMU.
full MMU, memory management unit, as
You have
opposed to,
very strict hardware requirements.
we have strict hardware requirements, as opposed to an MPU, which is
Right.
memory protection unit, which is in some microcontrollers, some are just linear memory, some of them. But in some microcontrollers, it's an MPU, which is memory protection unit, but doesn't offer the level of virtualization you need to achieve some of the separation between safety and not safety reliably. And then the monolithic versus the microkernel is another problem. But that's
Although a lot of times we'll partner with a FreeRTOS or a safe RTOS and take advantage of big Cortex M cores or the R cores. They don't have full MMUs. So we'll run on the A cores and then we'll partner.
I mean, Stephen demonstrated for one of our potential customers the ability to use OpenAMP to communicate from the master processor to the microcontrollers for other functions. So I mean, there's some cool things that he's had to do. He actually did the face thing. He finished it. Our engineering had started it, and then when we started, we're like, got 3 more things to do. How hard could it be? It was like it's a funny story from. Well, I didn't have to work.
It was just fun, and it really wasn't that much. But engineering was laser focused on our next generation. And they wouldn't devote any.
Yeah. It just was. It was time. It's me not bothering it for a week or 2.
Yeah, it literally, that's what I said. I said, Rich, take over for a bit. I'm gonna just put my head down, get it done. 2 weeks later.
I mean, sometimes that's what has to happen. Have to cover for each other. Well, I mean, when I was at Honeywell, there was always a good story of a program manager, and he said, it's a 1-line code change. How long could it take? So it took 7 months. Okay, because the 1-line code change broke the timing on the real-time process. It was inertial navigation, and it took another 7 months to refactor the code to get it down to where they thought it was, which was 50% usage. So it was like this famous quote when I was at Honeywell, this one guy. This is actually, this is the sensor from the autonomy standpoint. You want the ability to make it so you can use any LiDAR or any radar or any video, and the APIs are going to be the same. When we were talking about face spec there, they want the APIs to all be the same. What we've done is we've wrapped the sensors around there, and then we also provide, it doesn't say it here, but the read and record and playback and some of those other functions, so that now when you're going to simulation, you can bring the simulation environment with real world data from it. And then we have Robot OS. Who thinks Robot OS is an operating system? It says operating system right in it. It's sort of an operating system. It's an operating system for command and messaging, but it lives on other operating systems. It's not really it's, I would say, type 1 hypervisor. It's not really a type 1, it's not at the hardware level. But we support that, ROS 2 in this particular case. CAN, SOM, IP, AutoSAR, depending on who you're talking to, is a lot of the automotive companies will follow that spec as a way, but of providing integration a little more quickly. And all these are around standardizing not the products, standardizing the interfaces, standardizing the APIs, so that you can make it more reusable and more scalable. Black channel is actually a cool one that I like. Now I came from an inertial measurement unit world, which is what this little thing is supposed to be. But the black channel, what it does is at the application layer, it wraps the data so it stays safe no matter what it's transmitted across. So it's just an application layer mapping thing. I think it was designed for, actually for industrial. Or was it automotive?
Black channel?
Yeah.
I know we use a lot.
Yeah. It's just another layer so that you can make the safety case without having to have fully safety, you can have redundant paths and stuff. And then there's more on the security side. There's different security specs, 21434, common criteria for military government. There's specifications and trying to normalize some of that. And then supply chain security is kind of one of my hot buttons because it's actually not that hard to do, but most people don't do it because there's a lot you have to buy into to get that, and your nanny needs to buy into it. Trusted components, component isolation, and field monitoring. This is kind of along the lines of, public key infrastructure you mentioned when we were talking about introduction. What's the public key infrastructure do? You're generating cyber keys. What do you use the cyber keys for? You send them to your vendors that they can only build. I gave you 100 keys, you can only build 100. Because I know that if you build 101, that you had to use one of the same keys, or you had to have no key. So it's a way of not getting black channel or fake black market parts, black market, gray market parts into your products. You know, it's unfortunate, but I think you need to do that kind of stuff. And then security is about defense in depth. It's about wrapping. What can you tell me about the security of a device unless you have trusted hardware, unless you authenticate your ECU, your engine controller, unless when you're booting up, you're making sure that the key that's used in that image is the same key that you're expecting, so that you come up into a known state and nothing's been, nothing's been modified. Tamper protection, file system protection, image protection, making sure that what you're loading and the trusted boots, secure boots on the bottom, and then trusted boot as you get your images loaded and you load your guest operating system. Oh, wait a minute, that doesn't have the right signature. I can't load that. I'll go back to a default, so you don't switch over. Instead of switching over, you stick with the old one until you get one with the right key. Access control, we have a lot of things that we do on access control that are different from what you would do in an IT space, because the concept of users and embedded is quite a bit different than the concept of users in the IT space. So we use whitelisting of applications as opposed to users. Did you have a question? Okay, I thought you were. Application security, spatial control, controlling different where your application didn't get its data and put its data and get it back. So you're partitioning it. Safety and security are very much parallels in most instances, because the types of things that drive a safe application, like separation, are the same things that drive a secure application, separation. They're kind of like sisters. They need a lot of the same things, but they're completely different reasons. When you're doing a safe system, you're protecting the world from you. When you're doing a secure system, you're protecting you from the world. The way that people said thing. Yeah, I'd have to walk over. This is a virtualization one. What we did with the Android apps and audio video and Android 12 and 13, the Android applications today from Google, more and more they're using something called VirtIO, virtualized IO. Why? Because Google, Android, doesn't want to care what hardware you have. They want to update their operating system. So what we've done is we've done a wrapper or the back end for the drivers, and you have the virtualized drivers in the application, and then you can swap in Android 13 when you're using Android 12 with not as much modification to anything. You bring a process that takes weeks or months down to days or weeks. So you're just saying, I don't really care about what's going on there. I have algorithms. I want to work on my algorithms. You know, I worked for Honeywell when Honeywell designed computer boards. They don't design computer boards anymore. They get computer boards from Abaco or Curtiss-Wright or Ontron, whomever. People want to focus on what their value add is. And we want to focus on the foundation. And that's where hypervisors really come in, is being able to do that sort of thing. So that, we were working on a communication device with a customer where they want to completely bring in a new version of Android without having to worry about what was going on. This is kind of your slide. So a lot about the generalities of it. But what about space? What's different? Connected, shared data, and over-there updates. Quite a bit more challenging. You don't necessarily want to share all of your data. When do you share your data? These are all different things. Autonomy. Can you use the same kind of autonomous solutions? Now you need to look at the infrared. You need to look at the vision and use LiDAR and you use radar. There's no, many, many, many years ago, my dad was in sonar. Used to have pings. Remember sonar used to ping. The sub would ping. It would send out a beep, and then it would get back and it would map the environment. They don't do that because they're broadcasting what they are. And the other problem is like a lot of these autonomous systems rely on maps. What if you go where there's a bunch of trees? There may not be maps that are accurate enough for you to do that. You might not even have good maps of where you're going. Or you could put a new structure where there wasn't a structure before because you're somewhere. Shared services, that's a little more challenging. But there are points where you're going to want to do it, points where you're not. Electrification, I have a long-term disagreement on the electrification of all of the vehicles because of the infrastructure problems. What's that?
No, not then.
It's some of it is, and some of it's not. So if it was nuclear power, I would absolutely say absolutely. But the problems have become more centralized, which is good. But it's just not. People who say, oh, this one's better and that one's better. There's just a lot more to it than that. Is the only point I wanted to make. It's not that easy. And I know I can get gas anywhere, and if I'm in this country or in another country, it doesn't matter where I am. I might not be able to get electricity. It's just a problem.
And I don't want to have to plug in my tank before I go to.
Yeah, people think they're.
Yeah, but if you're in a
That you
war
can, in
situation,
both cases.
you're out there in the field, you may not have a place. It's just the infrastructure problem. Large, and you're always having to deal with that overnight.
It's just not that easy. None of these decisions, I've always taught my kids is that there's very few decisions that are made in total isolation. It's just not that easy. Oh, let's pass a rule that nobody can do this. It's like, well, but what about that person? Oh, there's nothing lives in isolation. You have to kind of solve the problem as a whole. And I just think that the electrification is one of those that's kind of getting there, but I think it needs a little more infrastructure. You asked about the vehicle infrastructure, or V2I, vehicle to vehicle communications, and a lot of that comes down to also the infrastructure and having all the stoplights have something in them where you can get information back. Or the crosswalk. Oh, there's a vehicle. So, and then what about somebody who has an older car? Are you going to just make them all obsolete on day one? It's just not that easy. That's all I'm saying. And then there's just different safety specs, and there's no in-vehicle infotainment. It's just a different world. Passive versus active sensors and inertial measurement unit is a passive sensor. Or camera, visual or infrared, or passive sensors. GPS is passive. It's just receiving from the satellite. It's active from the satellite, but it's not an active sensor. Odometry, whereas active radars and lidars are active sensors. So what are you going to do with, we have to do where we do the instrument panel and the in-vehicle infotainment, and you want to control them on the same computer, which is a different problem in the defense space. So the software-defined vehicles are maturing at a very high rate. We're partnered with MotorTrend, BlackBerry is partnered with MotorTrend on giving out some awards for that at CES this year. Each year I'm amazed with some of the technology and how fast it's going here. And some of that, if you're at CES, last year we had 3 or 4 vehicles. Yeah, at least 3 vehicles in a robot. We did a joint project with Texas Instruments, and that should have been a good one for UTD to be involved in. But we did a robotics program where we developed a robot with them, and then we have a bunch of data and other information online. You can get an evaluation copy of our software. You can get the plans for the robot. You can get a little bit of education on safety and what does it take to make it safe. So we have a lot of that kind of things, but the software-defined vehicles are moving at a rapid rate. Software-defined vehicles in defense are moving at a rapid rate, and I think you're going to start seeing you already see it. They're already talking about autonomy. Integrated compute platform. You know, the more powerful computers get, the more you can integrate into them. But there's going to be a point where you're going to modulate make more zone. And then off-road, on-road, which the off-road patches are active, and integrated compute platform seems to be up in flux. I've said it. But I appreciate this. This was unlocking the software-defined vehicle for defense innovation mining DesMarais. Stephen Olsen was over here as well. Thank you.
Any more questions, guys?
There are some cores that do lockstep. I've seen.
Most of those are R cores or M cores. I don't know if any, there might be some A cores.
I think there's an A core that does a lockstep. I don't remember which one it is because I think that sounds right. We support ARM v7 and ARM v8. So we already have a board support package for the A93 IDON-MX 93. IDON-MX 93, which is an ARM v8 architecture. And our newest operating system, which we didn't even talk about, is we have the microkernel infrastructure. We're adding a thread executive that gives you really fine grain when you want to improve the performance, but you get the microkernel for a lot of the safety functions and stuff like that. So I think what you'll see next from us is actually pretty exciting. We're getting higher speeds from higher efficiency in multi-core. Because if you've seen any of the charts, you go to 4 cores, you're getting about 3.8. And you go to 8 cores, you're getting about 6 cores worth of performance. And we did where we went from one millisecond message size to 16 core to sending a 16 times as much message, and we lost 52%. So we're getting a lot more scalability, and we think that's a game changer. I'll go there first.
I'm getting me too. You can't come in with close to this week. You want to have the car on the road and say go to Houston and Austin or something like that. You can get one. I'm just curious. I have a suspicion that I've been talking for maybe a year ago. I have a suspicion that even though
I don't share that. I think that you're probably going to get it in the trucking industry first.
well, they can go.
But that's rural.
That's highway.
But that's rural. It's,
Yes.
a lot of it's in rural. Some of it goes through city. Slow down in city. I think you'll see that more there, and part of that is a legal problem. Is that the trucking industry is going to have to take on liability for it.
Well,
I
they
think
can do
that's
it
part
if
of
they can city cooperate and improve stuff for the roads.
You can map the city. I think that you'll see it first in the trucking industry, and I think the more relevant to more people in this room will be some of the. This is my personal opinion. I think that some of the flying growth that are the air taxis will be the other area to see it a little bit more, because there's a limit to how much for the consumer that they want to automate and take on the liability. Whereas when you get into the air, believe it or not, to me, the air, you add up and down, but there's, when I got to drive across campus, there's 50 people, there's this, there's that, there's the signs. The signs are all stationary. And the roads are kind of stationary. They don't ever do construction here in Texas. Do they?
Not here in DFW, no.
Not here,
No.
not here, or in, no, Dallas. This road over here, what one of these expressways was, I came here for 10 years before the thing was out of construction. I don't even remember which one it is. It's an east-west road. Probably this one.
Oh, George Bush, yeah.
It was George Bush. So, and now I won't drive on it because I don't want to pay the car rental fee. It's there's construction, things are moving. Whereas you go into the air, you bring out a lot of elements if you're above the trees. If you're under the trees, then it's a lot more elements, and then you've got mountains and other objects that fly.
I would add that I was actually at a customer site 3-4 weeks ago, and they had a demonstration vehicle got in the car and drove through the Fremont about 20 minutes away, and the car drove herself on the road. It's a proof point to say that the technology can do it, that we're there. Certain companies have that technology, but illegal. I think another piece.
Good. Yeah.
Maybe they did the distinction between vehicle, drone, and robot, are they set off?
I mean, they're all vehicles. They're all autonomous in an extent, but the types of problems you have to solve are different in certain ways. But it's like, I used to tell people all the time who weren't in my industry that I'd go to Whirlpool making refrigerators, and I'd go to another guy making satellites, and I'd go to another guy making medical equipment. And it's computer, memory, operating system. It's all the same things with completely different sensors and actuators. They're all the same problem in a lot of ways. Now, the rigor with which you need to do that, and one of the reasons you asked about AI, safe AI, is that you can't adapt in the field yet and still maintain a safe system. You have to check it. You have to make sure that what your algorithm you came up with is safe. So you can't quite do that today, which is one of my pet peeves about, let's put AI in it. It's like, you just solved the easiest problem in the world. You got the sine wave out of the data. I mean, sometimes people are over applying it, is my point.
One last question, guys.
Go ahead. Yeah. Oh, is it yours?
Nope.
Oh, okay. I thought you were just telling everybody else they're done. You keep seeing the, go ahead.
So there's tons of things that do. These types of products.
We have a couple products. One we don't even work on. It's called Radar, BlackBerry Radar, which sits into a container and measure whether it's full or empty and track where it is. And you can track your assets that way. And then I think just us doing the autonomy and a lot of the stuff and the what we talked about was called, I'll get you in something. The BlackBerry Ivy was that product that collected all the data into the cloud and then gave you an infrastructure for it. That's kind of getting into that level. I did not see that.
Okay, no, I didn't know you mentioned that.
Yeah, and Radar is BlackBerry has a product called Radar. And Radar is in the back, it sits on a container and measures whether it's empty or full, gives you, and it's way to manage multiple containers. But Stephen and I have worked on
I
it.
want to talk.
It's cool, but we don't work on it.
Last question, Andrew. Did you have one?
I believe that.
No, go ahead. Ask your question. We got him here, so this is awesome.
The comments, I let you and I also follow me to everything. I with my do if you legal recognition for the 10 years from now, if my book any stuff that can cost you more. Well,
I could see that flip happening. Well, the reality is that, well, the reality is that humans are much less safe than the autonomous vehicles. And that probably will flip hopefully during our lifetime. I want to live that long, but so. Oh, Uber, hit one person. Name how many, there's not a lot of people that have gone 100,000 miles, driven 100,000 miles without an accident, and there's quite a few.
Let's give him a hand, guys.
Thanks, guys.
Appreciate it.